So we can get started. Here is a slide. These are the resources for this presentation. Some extra above and beyond stuff that I'm going to present in the slides, including a copy of the slides. There's the feedback link, which we're sort of obligated to put in there. Some of you guys grabbed some of these RFID tags. If you walked in late, I've got these tags programmed to go to the same place as that QR code. So it might be a little bit more convenient. So my name is Jarrod. I work for Menlo Park City School District out in California. I am in charge of all of their security stuff. And one of the things that I had to do was secure our email. I don't know why they put me in charge of that, but somebody thought I could do a good job. So today we will not be covering email encryption methods. That is a way to encrypt email in flight. We won't be touching that. We won't be touching on some of the underlying technology like SMTP, the handshakes and stuff like that. Instead, we are going to be focusing on how to authenticate email and thereby hopefully stop spammers and people masquerading as your people in your organization. We're going to stop those Nigerian princes. That's kind of the goal. Why are we doing this? Because email is the #1 target or vector for infection and for targeting both scams, spam, spyware. 80% of it comes from email easily. I would guarantee that almost every single person in this room has probably received an email.
Your slides are hard to read back here. Can we turn the light on or something?
Yeah, we could probably do that. Let's see. Apparently that's not lights. Might need to grab someone in the back there to do that. I'm not sure how the lights work in the room.
Or is it just me?
No, they're not great. I apologize for the slides. I am not an artist. These are kind of ugly slides, but they should be functional, assuming we can see them. Let's see. Oh, that works. Now we're in the dark. Perfect. Is that better? Okay, so as I was saying, I'm confident saying that everybody in this room and probably everybody that watches this recording has received an email that claimed to be from somebody that probably wasn't. Be that a Nigerian prince, be that Bill Gates, you name it. So that's why we're here. So I'm going to run through a couple of brief history on email. So as some of you may not realize, but 1960 was when they first started with this concept of they didn't call it email, but the electronic mail, and that was when the first electronic message was sent via what would ultimately become email at MIT. Then in 1971, Ray Tomlinson sent the first email, marking the birth of modern communication. He chose, interesting fact, he chose the @ symbol to separate the username from the server, which was something that stuck around, as you know. In 1976, Queen Elizabeth became the first head of state to send the first email. She sent it as a demonstration over the ARPANET. And if you're interested, that's what the email said. Very, very, very English in that it was completely functional rather than anything else. So my notes, you can read that in more detail. And then in 1978, someone got the grand idea of using this wonderful new communication method to do some marketing. And he sent out the first spam message. It was sent to about 393 people, most of whom were not interested in it, but one or two actually did show up to the event that he was advertising. Again, it flashed really quick there. In my notes, I actually have a copy of his email that he sent. It was advertising some deck equipment. They were trying to organize basically a sales thing. And then 1978, Shiva Adwari, hopefully I pronounced that right, with some help from his professor, he developed the actual concept of email, and I believe he worked on the SMTP protocol. And interestingly, he has the copyright for the concept of email. So he's the official creator of email as we know it, including the term email. In the 1980s, they used SMTP. MCI launched the first commercial email service. I think that was somewhere in the early 80s. And by the 1990s, you started seeing widespread adoption in homes through AOL, Yahoo, and some of the other bigger ISPs. And Microsoft purchased Hotmail sometime in the, I want to say, mid-90s. And it became the most popular web-based email service to begin with. And then in around early 93, 94, the term spam was coined, which came from Monty Python sketches, which is a nice nod to spam. because they used the word excessively, so someone thought it was a good idea to name it spam, and it kind of stuck. That year, we also had the first mass Usenet post advertisements that went out from two lawyers. It was known as the green card spam. Basically, they were advertising their law firm, trying to get people green cards, and they sent it out to quite a few people, and that was the first major commercial spam we saw. I mean, the first one was very small scale, but that one was much larger scale. It did not go down well. In the late 90s, Microsoft purchased Hotmail for $400 million. And at that time, spammers started to realize that the spam thing actually kind of worked. Like if they hit enough people, some people would respond and they'd make money. So spam started rising significantly. And right about the late 90s is when people started developing this concept of spam bots. They started essentially automating the spam. And it started rising dramatically. In the 2000s, Congress took notice of the spam issue, and they decided they needed to do something about it. So they came together and they created this CAN-SPAM Act of 2003 to regulate commercial email and combat spam. That's when you started seeing that unsubscribe was a mandatory feature of spam that went out. SPF was created in about 2003 because we started realizing we had the problem of knowing who the email came from. They needed a way to validate that it was coming from who it said it was, and then DKIM followed that in 2004 because they needed a way to further authenticate said emails. SPF came about as a way to verify the server that was sending the email, whereas DKIM came about as a way to verify that the email was from who it said it was from. And then in 2010s, DMARC was created to that mix, and that was a way they realized fairly quickly, they realized quickly, but it took a while for it to become a standard, that they needed a way to put those technologies together and create some sort of reporting / control for the people sending email, and that's kind of where that came from. Because by the 2000s, spam and that kind of thing had become a major issue, and scammers had jumped in on the boat at some point and started really scamming people. All right, so the question is, why are we here? I think the history pretty much goes through that. One of the biggest challenges, and I have these 3 points here, but ultimately the biggest challenge in email these days is that concept of authentication. How do we verify that when I get an email from Queen Elizabeth, how do I verify that it is in fact from Queen Elizabeth and not some guy in Nigeria who's trying to scam me out of money? That's a big part of it. So to do that, we're going to leverage 3 things. We've got the SPF, which most people have probably heard of at this point because it was the earliest of the technologies. We've got domain keys identified mail, or just referred to as DKIM. That's a way to sign the email. And then we've got domain-based messaging, authentication, reporting, and conformance, DMARC. And that's a way of tying everything together and getting that reporting part of it. All right, so SPF. I think most of you probably set up SPF if you're doing it. But basically, all 3 of these technologies rely on DNS, which is great. Because email back in the day was designed, it was never designed from the ground up to be secure. It was designed to be pretty much trust everyone. So modifying email at this point, or the underlying protocols to email, is not really an option. So some very smart people got together and they worked out how to use these technologies and sort of bolt them on, and they leveraged DNS primarily to do that. So SPF is a DNS text record, and essentially it lists all the servers that you, as a system administrator, are authorizing to send email from your controlled domains. There are what they call mechanisms inside of the SPF record, which allows us to configure these things to be quite reasonably flexible. You start off with the V tag or the V mechanism. It's always SPF1. That sets the SPF version. And currently there is only one version, so that will always be SPF1. At some point, if they roll out an SPF2, then we'd be able to bump that up to 2. The next part of the mechanism is the MX mechanism, which basically states that the MX record for your domain is authorized to send email from that domain. So that uses DNS. So when email comes from your domain, The receiving server will check your DNS, check what the MX server is, compare that IP to where the email actually came from, and if it matches, then it'll pass the email through. The next mechanism that's most commonly used is the IP mechanism. This allows you to specify explicitly which IPs can send email on behalf of your domain, IPv versus IP6. And the include mechanism allows you to include third-party domains into your email chain. So what that does is that includes the SPF record for domain.com. So if you are having domain.com send email on your behalf, that include will allow that to happen because it'll include all of their email sending servers. And then this last mechanism, which is the all mechanism, tells the emailing server what to do if there is a match. The plus is pass. It'll pass the email. Step back. That mechanism is a catch-all. That catches any email that doesn't match anything else in the SPF record. So if it matches the MX record, it'll pass it through. If it matches the IP4 record, it'll pass it through. If it matches the include as part of the domain.com, it'll pass it through. If it doesn't match any of those, it then looks at this last mechanism to determine what does it do with that email. Negative all means that it will fail. Everything that is not explicitly allowed will then fail. You have the plus, which will essentially pass everything that doesn't match any of the other records. Wouldn't recommend you do that because that kind of invalidates pretty much everything else in the record. The question mark is for neutral. Now neutral, you don't necessarily know what's going to happen on the sending server because the receiving server can determine what they want to do with a neutral response. Some will fail it, some will pass it. And then last but not least, you have the tilde, which is a soft fail, which again, you don't necessarily know what the receiving server is going to do with that, but the majority of them will pass it to the user, but mark it. So the user will receive an email and it'll be marked as spam or quarantine or something like that. So there are a couple of different SPF results. You've got the pass, which is pretty self-explanatory. That means they'll accept the email and they'll deliver it to your end user. You've got the fail condition where the receiving server will reject that email. The end user will never see it. And then you have the soft fail, which is the tilde. As I explained, it will receive the email, it'll mark it as spam, and it will deliver it to the end user, assuming the receiving server has that set up. Some receiving servers choose not to accept those, and they will reject the soft fail. You have the neutral response, like I said, will vary depending on the receiving server. Some will receive it, some will not. I think in this day and age, most will probably reject it, but I'm not sure. And then there is the none. If there's no SPF record, the default is to deliver the email. So you should definitely have an SPF. Well, that's changing in the industry, but up until fairly recently, none would still pass through to the end user. I think more and more receiving servers are choosing to now kick out email that does not have SPF. Because at this point, we're a decade into SPF, and most domains should have it. And then, of course, because it relies on email, there are these two responses where you have a permanent error and a temporary error. Because it's reliant on DNS, DNS could fail. And that's when you'll end up with a temporary error where you have a transient error, and generally it'll reject that. And then when you run into a permanent error, the reason why it's unspecified is that's another error condition where the receiving server will accept it or not, depending on how the admin has it set up. All right, so here are some best practices with SPF. Since SPF controls who can send email on your domain, you want to try and be as specific as possible. You want to validate your SPF records, and you want to remove anything that is not necessary. If you're a Google shop and you have Google included in your SPF record, and then you guys move away from Google, you move to Office 365, don't leave the Google records there. Remove them. Add in the Office 365, remove any unnecessary ones. Standard practice today is to avoid the A mechanism and the MX record mechanism. The way modern email is set up, that MX record is just not as relevant as it once was. Most people send email from totally different servers in their domain. Some don't, but you generally speaking want to avoid that one. The A mechanism is similar to the MX record. You can tell SPF, you can tell the receiving server to check DNS for the A record for something and use that. You want to generally avoid that. You want to be very careful with the include mechanism. Because the include mechanism is not very transparent to you when you set this up, you don't know what the other server, what the other company is using as part of their SPF. They may not take this very seriously, and they may include half the world's emailing servers. So you want to make sure, when you add and include, you want to make sure you know what you're adding. You want to use the IP mechanism rather than the domain mechanism to flatten the SPF record. Now, the concept of flattening is very important when it comes to SPF because SPF will not do any more than 10 lookups. When a receiving server gets that email and they go and they start looking up the DNS records, they will do 10 record lookups, and at number 11, they will stop. So if your email would have matched lookup number 11, it'll fail because SPF will not go beyond 10. So you want to be careful when you craft this mechanism such that you don't have 10 lookups. And that's where the IP mechanism comes in handy. So rather than adding a domain to your SPF record, you can add an explicit IP, and there's no lookup needed at that point. All right. When you use the IP mechanism, it is a CIDR-based format, so it's got the subnet at the end of it, so you could theoretically add an entire huge subnet to that IP. It could be 192.168.0.1:24, for instance, and that'd be 255 IPs if I'm not mistaken. So you want to be careful with that. I would tend to suggest that if you're going to use the IP mechanism, add a single IP as opposed to multiples. As a side note, if you do not specify the subnet, it assumes that you mean a single IP. So it's assuming, I believe, a /32 at that point. And then the last, I think it's the last bullet, yeah. You want to consider any domains that you have. Actually, that's a theme throughout this as I'm talking. Thinking about the other domains that you own and control that are not used for email. You may want to consider adding an SPF record that looks like that, SPF1 and then -all, for those non-email domains. Because what that will do is if anybody tries to send email from that domain, it'll automatically be rejected. So if you have a subdomain that you expect email will never come from, doing that will just about guarantee that email will never be delivered if someone tries to send email from that domain. But keep that in mind. If you ever decide to add email to that domain, you'll want to change that. And then last but not least, big thing, you want to be as explicit as possible. With SPF, you want to be as explicit as opposed to general. So you want to narrow it down as much as possible. All right, so I'm going to go ahead. There are some tools to go ahead and validate SPF and look them up. So we'll go ahead and do that right now. I got to click that. There are tons of tools out there that do this. These are the two that I tend to work with. So if I enter my domain in here, what's nice about these tools is hopefully the internet works for me. Okay, this will give you some nice results there. So it'll tell you that your SPF record is valid. Oh, whatever. It's advertising itself. Yeah, maybe later. This will tell you, this is nice. It'll give you, like I said, it tells you the number of lookups you've got. Mine is 6 out of 10. And it tells you the net block, the number of IPs that I've got set for that. 46 is kind of high, but being a school district, we use a lot of third-party applications that email on our behalf, like PowerSchool and stuff like that. So that's probably higher than I would like, but it's as narrow as we could really get it. And then there it gives you a copy of the SPF record. That's what ours looks like. As you can see, I can use it over here. I got to do that. As you can see, we include Google's SPF records. I've got some explicit IPs that we control. And we also include the KnowBe4 SPF because we use them for phishing testing. And you'll notice that I've got the -all. So anything that doesn't match gets rejected. And this even goes so far as to show you all of the lookups, which is really quite useful. That's a lot of IPs. Another tool that I use is MX Toolbox, which is not quite as nice, but it's a little bit, depending on how your mind works, the output might be a little bit easier to read. Same thing, gives me a copy of my SPF record, runs through each of the things, gives me an idea of what that does, and then it just does a general health check. So these tools are invaluable when you're trying to troubleshoot SPF. I think it was, the war. Why did that not work? Maybe .gov. Yeah, so our whitehouse.gov is pretty nicely set up there. Okay.
Don't accidentally type in whitehouse.com.
Not anymore. They bought that domain.
Oh, did they?
Yeah, they bought that domain. That'll take you to the White House website now. But yes, I remember that. Being in a school district, yes, we're very familiar with that mistake. All right, so I'm going to do Q&A between each of the three different technologies because they are different, and we'll do Q&A at the end. So we're going to pause here. If anybody have any questions about SPF? No?
I'll make a comment. Something I recently read was that.
Here, I need to throw this at you. Otherwise, it won't be on a recording. Oh, sorry.
Yeah, recently I was reading some discussion about using soft fail versus hard fail.
Mhm.
And they indicated it's better to soft fail it because SPF can sometimes be just a little weird and let it go on to DKIM because it's either signed or not. And let it fail DKIM rather than forcing it to fail SPF.
Yeah, so when we get to DMARC, that's covered in kind of you'll see how that sort of things.
Comment.
Yeah.
I didn't know if you had any thoughts about that.
The only thought and mention I can say with that is these technologies were designed with the idea that we don't want to interfere with email deliverability. So they tend to fail open. In other words, they tend to fail with the email being delivered. The idea being it's better to deliver the message than not deliver the message. In other words, take the risk of getting a few false, or take the risk of getting a few spam emails as opposed to getting in the way of legitimate email. So SPF is the same thing. So that's why soft fail will generally deliver, and hard fail will not in some cases. And again, the receiving server has some control over these mechanisms to some degree. They can dictate what happens in those situations. So depending on your risk tolerances, you can set it up specifically for that. But the key here is they tend to fail in a way that the message gets delivered because they don't want to accidentally not deliver legitimate email. Any other questions about SPF?
So this makes sense. Like, thanks for going through these, like point by point. This is how you read it. This is how you assess it. Do you have and this coming later? Great. Do you have a recommended resource for if new clients brought on, we take a look at what they already have. Do you have something you'd say like, oh, try jumping to this website's a great guide for you are starting from nothing. These are the things you should probably put in to begin.
The resources out there are a dime a dozen. The MX Toolbox, I think, in my opinion, from what I've seen, has the best documentation breaking down the individual mechanisms individually. That's what I tend to use. However, DMARCian has some really good resources as well. So the information is formatted slightly differently. What I like about MX Toolbox is it's a table, and it gives you a summary of each mechanism. Then you can click on the mechanism, and then it gives you more in-depth, deep detail of that mechanism. So I think that answers your question.
A little more of being able to assess what's currently introduction is one thing. But if I have a client who comes to me with a brand new domain, they're starting a new company, and they say, we haven't set up any of this yet. Are you aware of some that would be like a PDF or a guide of, now that I understand what the records look like, how to go about actually implementing it?
Not really, not that I can think of. It's like building a Linux command. It's more akin to that. You bring up the man page, you see what your options are, and you kind of determine which are your best options. It's very similar with all three of these technologies. You look up the various mechanisms, and you kind of have to determine which mechanisms you want to implement as part of the record. Yeah, and there are AI tools out there that can build starting records as well. So there's lots of guides out there that you can basically punch in a bunch of details and it'll spit out a reasonably good starting point for that. ChatGPT could probably do that now I'm thinking about it. There aren't that many mechanisms, so going through the documentation on what all the mechanisms do is not particularly time intensive. All right, go ahead.
Maybe this is a bit thinking out loud, but this isn't marking mail as being questionable. This is deleting it on the server side, basically.
Well, rejecting it would mean not receiving it, yeah.
Okay, so it's not just that the person gets it and it's in their inbox, it's in their spam. They never see it. So a user would call and say, somebody tried to send me a mail, I didn't get it.
Depending on which of these responses you get, will dictate whether they see it or not.
And that's something the email receiver server
Does, correct.
and decides.
Yeah, so like I said, you've got pass, it'll accept it, delivers on, not a problem. You've got fail, the server will reject that email. It will not even get to the store, let alone the end user.
And reject is not just it doesn't give a bounce back, it's just
Straight, well,
or
depending on how you have it configured on your end, reject could mean that it shoots back to the sender saying unable to deliver, or it could mean you just reject it with no message.
okay.
Depends on what you're using. Now, the spam that you're mentioning, that's when you run into the soft fail, potentially the neutral, and potentially the none.
Okay.
Or one of the
So soft
or the
fail
perm error.
could be delivered to the client,
Correct.
maybe, depending on what the receiver's server chose.
Yep.
And their client can decide,
Correct.
hey, I see this one says the SPF didn't pass, so therefore.
Yeah, as I said earlier, this is built so that it fails in a way that it errs on the side of delivering the message. So it'll, generally speaking, and again, it's hard to say specifics because it really depends on how the end server is, the receiving server is set up. But generally speaking, they'll err on the side of delivery as opposed to reject. You'll only see rejections when it is explicitly obvious that it needs to be rejected. I have that email server set up to send my email. The email's coming from this other server. My SPF record explicitly states that that is the only server that sends email. This receiver will reject it. When you run into that gray area of could it be, could it not be, that's when you'll see it generally move towards that spam, marking as spam, putting it in a spam folder, getting to the end user, or getting to some sort of global spam mailbox that some admin can review and go, well, no, that's actually fine. If you're receiving, troubleshooting email is a royal pain because you don't have control over the people sending the email. If somebody's screwed up their SPF record, you can't fix that. And then of course you got end users yelling at you going, hey, fix this email. Why am I not getting email from so-and-so? Well, because their IT person's an idiot. I spent 6 months once trying to chase down an IT admin at another organization because we were not getting their emails. And they were just ignoring me because they couldn't have cared less. Eventually I had to elevate it through our superintendent, went through their CEO and got it higher up in the chain. And when the guy eventually did call me, he was not very happy. But he'd been ignoring me for 6 months. So. There's some light at the end of that tunnel, and we'll get to that. That's what DMARC does for us, which is really nice. So domain key identified mail, DKIM. This is an even simpler concept. This is literally just signing email with a cryptographic key. So it's an authentication method where the sending server uses a private key to sign the email and send it on its way, and then the receiving server can then grab that public key and verify the email. So I got this meme in here because it's PKI. It's public key infrastructure is what this uses. So step one, I'm going to go through how this works. Again, it's very dry, so I apologize for this. This is not a very humorous subject, but it's an important one. So step one is the sending email server generates 2 hashes, one for the body and one for the headers. It then generates a cryptographic key using the private key. And then last but not least, it inserts that key and hash into info on where to get the public key for the DKIM header. So that inserts that into another header inside of the email. That's a key point for DKIM. Everything the receiving server needs to validate that signature and validate that email is included in the email, in one of the headers. So the receiving email server receives the email. It then generates its own hashes based on the header and the body. It then compares those hashes to the included hashes that were inserted into the main header. What's nice about that is that helps the receiving server validate that the email was not changed in flight. So it was not intercepted. If the hashes match, then you can be reasonably sure that no one grabbed it out of the ether, modified it, and sent it on its way, which is a thing that happens, by the way. The sending receiver then uses the information again in the header to reach out to the DNS server of the sending server, and it grabs the public key. Using that public key, it is then able to then validate the signing key. So at that point, this is part of the reason. This step 6 is part of the reason why DMARC exists. But so once it's validated that stuff, it can send it along, and now we're 100% okay. The thing is, if it cannot validate the signature, it still delivers the email. I assume that the receiving server might have some control over that to some degree, because I mean, all bets are off when you control the server. But as an industry standard, if DKIM fails by itself, it's not an indicator not to deliver the mail. Because again, these technologies, they fail open essentially. So, like SPF, DKIM is just as a text record. It's an even simpler text record. So that is what I'm not going to cover the DNS technology, but that's essentially what it would look like in Bind 9. So in Bind, that's what the record would look like. Your DNS record setup could be completely different. If you're a Microsoft shop, I think it'll be a very different looking text record. So again, you have the V tag, which specifies the version. Currently, the only version is version 1. One thing you will note that's different from SPF, and I don't know why DMARC and DKIM does this, but that semicolon is very important. You need the semicolon for DKIM and DMARC. You don't need it for SPF. I don't know why. The K key specifies what kind of encryption you are using. RSA is pretty universally supported. The key to this is whatever encryption method you're using needs to be supported by both ends. If your receiving server does not support your method of encryption, it will not be able to decrypt that key and match those keys. And then P equals, and that's your public key. Long string of letters and numbers if anybody's ever seen one. Now, the obvious question with regards to the public key is, well, where do you get the public key? You have to get that from the sending server. If you are a Microsoft shop, you'll need to get it from Microsoft. If you're a Google shop, you'll need to go into your Google admin console and you'll need to get it from there. If you run your own email server, depending on your software, you'll need to look up on how you generate that key. All right, so best practices here is you want a key length of, these will match most cryptographic best practices. You want a key length of at least 1024, 2048, 4096, more is better. You want to use SHA 256 or better because SHA 1 obviously is deprecated, it's easy to crack. And then you need to rotate that key probably at least twice a year. I think that's probably one that most people run afoul of. I know we don't rotate our key. I need to probably do that. That just helps against compromise. If somebody does somehow manage to get your private key, rotating the keys will help avoid that. Okay, so we can go ahead and demo this. This one is much easier to get through because, like I said, it's a bit of a simpler concept. So again, we'll go back to demoing, and I will just use myself as a guinea pig, and we'll DKIM here. One thing I didn't cover in the slides, and I thought I had it in my notes, but I guess not, is with DKIM you need a selector. And that is specified in the record. I must have left that out on the slide, so that's an error. So you'll see there's what our public key looks like. Again, you've got the DKIM version 1. We're using an RSA key. That's what the public key looks like. It's 2048. So the selector is, so you'll see where it says query and it says Google._domain keys. The selector is Google. That's going to vary by domain as well. I think that has something to do with how it generates the key. Google's tends to be Google. I don't know what Microsoft tends to use, but it doesn't, it's something you will get from your email provider. They'll be able to give that to you and you include that as part of the record. And in order, yeah. And then you can see here, it goes through, it tells you what they are. There's not much more to the record than that. So if you don't have DKIM set up, you definitely want to look into having that set up. That comes later. So I'm going to stop there and ask if there are any questions on DKIM. One thing to note about DKIM when it comes to troubleshooting, it's a challenge because you may not, or you probably do not have access to the private key, so you can't verify the key. You can verify the record, but my guess is if you're getting some sort of error that seems to hint that the key doesn't match, just regenerate the keys. All right. Go ahead.
Some DNS systems won't handle a 2048 or larger bit key unless you split it.
Yeah.
And there are key splitting services online where you can paste in the big key and it will split it into pieces so you can make multiple text records. And some of them don't tell you. You paste in your 2048-bit key and it just says error.
Yeah, I would probably lean towards a smaller key than splitting it because you never know what the receiving email is going to do. Some may have no problem with that, others may not recognize that. By the time you hit 1,024 bytes with a key, you're pretty set, at least for today. Maybe 10 years from now, you might not be. With cryptography, you know, quantum computing, which is kind of on the horizon, maybe depending on your viewpoint, that's going to invalidate a lot of this anyway. But it's better to have a weaker key than no key. But I would almost always err, for this use, I would err on the side of 1,024 or 2048 if it'll fit in your DNS. I'm going to send a catch box back there.
Do you have any recommendations for working with like outside vendors, like MailChimp or anything like that? Because I find that I try to set it up perfectly. Like my domain's fine, but like when I try to add them, like it fails.
Yeah, if you are using a mass emailer to send out stuff like that, with the changes that Yahoo and Google did a couple of months ago, that's become a lot more complicated. Constant Contact is one we use. And when Microsoft and Yahoo made that change, they stopped being able to send. And they panicked because they didn't have DKIM or SPF or anything set up properly. My recommendation, if you're going to use a mass mailer, don't send it from your domain. Send it from their domain. Your life will be so much easier if you can get people on board for that. If it has to be part of your domain, that's when you're now using that include record. Yeah. And now you're trusting that MailChimp has their SPF created correctly. So you're kind of putting a lot of trust in them at that point. So my recommendation, if at all possible, have them send email from their domain, not your domain. On the end there. Oh.
My wife has worked for a couple of very large companies, and they put her through training saying, don't trust any email that claims to be about us, but it's not from our domain. And then the HR department farms out emails about how to use your retirement account that come from other domains. So I understand your comment, but it's like everybody's being contradictory in real time.
Yeah, we run into the same problem. We do the know before training, and it's got people on edge because they're looking for these emails. And then our HR department sends out an email that looks like exactly like the know before training emails. And then HR is coming us going, well, nobody's signing up for this thing. Well, you're sending a generic email that looks like the spam emails. Of course nobody's signing up for it. Yeah, it's a balancing act, unfortunately. But with the changes that Microsoft and Yahoo and a couple others recently made, it's becoming more and more difficult to have those mass emails come from your domain. I'm not saying it's impossible. It's doable, but it is a challenge, and it does potentially open you up to some attacks there, because now you're incorporating things that you don't control into an element that you are supposed to control. And again, it's going to come back to whatever your company's risk tolerance is with regards to that. We are public education, so we get a lot of those spoofing emails where someone emails claiming to be our superintendent, and it's going to our CTO. Hey, I need 25 Apple gift cards purchased. Can you just go ahead and do that? Don't call me. I can't answer right now because I'm in a meeting. And it's coming from some random individual. It's not from our domain. So our risk tolerance is, at this point, such that I've driven as many people, when we send out mass mailing, it's coming from somebody else's domain, not ours. It's a fun time to be alive. All right, now it may seem like I've blasted through SPF and DKIM, because I kind of have, because this is the meat of the presentation, quite frankly. DMARC is a bit more complex to set up. There's a lot more bells and whistles. So with SPF and with DKIM, as you could see, they're not perfect. They fail in a way that email still gets sent. There's no visibility on your end as to what might be happening to your email when it goes out into the wild, wild west or the wild world there. You have no way of knowing whether your email is being delivered or not, because you may get a bounce back, you may not get a bounce back, depending on that. So DMARC enters the fray. It took them nearly 10 years to get the standard ratified. But basically, DMARC is an email authentication method built to leverage both SPF and DKIM, and it adds in some reporting options. The reporting options are really nice and really cool. And it gives us, as admins, better visibility into our email, but also a little bit more control. We can now, with DMARC, we can now dictate to some degree what happens to our email when it doesn't pass those other technologies. So DMARC, the receiving server will, this is how it works. The receiving server will check the DNS for the record, and it'll look in the from header. They specifically chose the from header for this technology because it is the most usable, the most visible element of an email to the end user. All the end users can see the from field. That's how the email client lists the email. So when it comes from someone at yahoo.com, and an end user opens up their Yahoo inbox and they see this email from somebody at yahoo.com, that's from the from header. It's also one of the few that's universally supported. So they deliberately chose that header for that reason. So then the step 2 is, as usual, the receiving server will do an SPF check and will do a DKIM check, and it will note the results. Then it'll go ahead and use the DMARC record to work out what it needs to do with those results based on those SPF and DKIM results. Okay, so here are some terms that are going to be kind of important when you start talking about DMARC. You have authenticated identifiers, SPF and DKIM. Who knows, maybe down the road there'll be some more they'll add to that. But the term authenticated identifiers refers to those technologies. So the technologies used to authenticate DMARC. You have when they say identifier alignment. So if SPF passes, you can say that identifier is in alignment. If DMARC passes, then you can say that identifier is in alignment. Then you have domain alignment, where either or both SPF and DKIM pass that alignment test. So if one or both are in alignment, you can then say that the domain is in alignment. DMARC also brings into this concept of an organizational domain. That is the shortest domain that remains within the, well, that's a weird way of saying it. I don't know what I was thinking there. But that is the shortest domain that's under the TLD. So the organizational domain for Microsoft would be Microsoft.com. It gets a little bit more complex when you start talking about subdomains, because that organizational domain could theoretically shift down that path. So it could be, you know, internal dot, well, it could be some department dot some domain. But generally speaking, when you're referring to the organizational domain, you're talking about the top level domain. So these are some important facts to know about DMARC. These are kind of important concepts. DMARC will pass if SPF or DKIM passes. It's an either or. If SPF passes and DKIM fails, DMARC will pass. If DKIM passes but SPF fails, DMARC will still pass. So this goes back to your point earlier. One of them has to pass for DMARC to pass, not both. DMARC will not do more than 2 DNS lookups. And this like I've noted here, this will come into play with certain subdomain setups. I would say 80–90% of your setups out there, this is not even going to be a consideration. But if you have a complex setup where you are sending domain from multiple subdomains, this might come into play. Okay. So like SPF, DMARC records are just DNS tax records. And here's bind, again, the format for bind 9. You'll notice the _dmarc.domain.com. I had to shorten it to DMN to fit it on the slide, but that's a generic domain. The _dmarc is important. That identifies this record as a DMARC record. So whoever your DNS provider is, you'll need to go from there. We use bind, so it's command line based and it's a text file configuration, so that's why that's important. But if you use something that's got a GUI, it'll probably have a DMARC entry that you can edit, and it'll take care of that for you. So again, you have the V equals DMARC 1. Currently there is only one DMARC version. I left a semicolon off of the V there. There should be a semicolon there. It's a mistake. So P equals none. That is an example of the most simplest DMARC record you can have. That would pass, with the exception of the semicolon, that would pass as a valid DMARC record. But don't do that, because what that will do is that will pass all email through DMARC. It won't stop anything, and it does nothing. All right, so you have several DMARC tags. There's quite a few of them, so bear with me here. You have the P record, which provides the receiving mail server with a command of what to do with the email that fails. So P tells the server what to do if it fails. There are 3 options: do nothing, reject, or quarantine. If you are starting with DMARC, you probably want to start with quarantine for testing purposes, but you want to eventually get to reject. Most DMARC records today are probably going to be set to quarantine, but your ultimate goal, I'll re-emphasize that, your ultimate goal is to get to reject. You don't want email delivered that fails DMARC. So none equals take no action, quarantine, mark as spam, and then reject is outright reject the email. So again, just to emphasize, you want to get to reject eventually. Start with quarantine. Actually, you could start with none, but I wouldn't do that. I would start with quarantine. All right, the next tag we've got is PCT, which is the percentage of emails that fail. This is again, great for rolling it out and for testing. Start with a low percentage, 25%, and then kind of work your way up as you're testing this and validating this technology. What this does is it tells the receiving server to fail that percentage of emails, and anything past that, it will no longer fail. So that's why it's good for rolling it out to begin with. Because if you set this to 25%, the first 25% of emails that that receiver gets that have failed will do whatever your the P tag does. So once you hit that 25% mark, it essentially will ignore what the P tag tells it to do, and it'll deliver the email. Again, great for rolling it out to start. You want to get to 100% over time. Then you have the RI tag, which is the report interval tag. This dictates how often you will get the reports from DMARC. By default, it's 24 hours. You can't set it below 24 hours, but you could set it above 24 hours. And I believe it's in seconds.
Is that percentage part of the report?
Yeah, it'll report everything, though. It's a good question. I would assume that it would report everything, but I'm not sure. You're guaranteed reporting on that 25% if that's where you start at. I'm not sure about the above that. Because the reporting, you might not get above that because the reporting will only report on fails. It doesn't report successes.
And it doesn't say, I'm done doing that.
No, probably not. 24 hours is probably good. I would probably, if you leave RI out completely, it's going to assume 24 hours. And that's an aggregate report. I've got some more detail on reporting later on in the slide, but suffice it to say that there's two different kinds of reports that DMARC can generate for you. There's an aggregate and then there's an individual. The RI sets the time period for the aggregate report. Once a day is probably about right. Once you get more confident, you could increase that, but I can't for the life of me think why you'd want to. I mean, I guess if you are an organization that sends millions and millions of emails, maybe you'd want it weekly. But I mean, we send tens of thousands of emails and 24 hours seems to be about right for our reporting. SP is a tag used for subdomains. It's basically, think of it as a P tag, but for a subdomain. Subdomain policy uses the same option. Yeah, so it's for subdomains. I'm trying to remember that applies down the chain, I think. All right, some more tags. There's lots of tags. ASPF and ADKIM sets the alignment handling for SPF and DKIM. It compares the mail from to the from domain. And then you go into, okay, so what this does is this checks the mail from header and it compares it to the from header. I don't know how complex, well, email has multiple headers and the way that it's set up, the mail from header doesn't have to match the from header. The from header is literally what gets displayed to the end user. The mail from is theoretically where the mail is actually from. The two can be very different. So you can set DMARC on how to handle that. Relaxed mode will pass if the from domain is a subdomain of the mail from domain. So if your mail from is your top level domain and the from domain is a subdomain, so if your mail is from mail.com, if your mail from domain is mail.com and your from, this is very confusing, wonderfully confusing. So the from domain might be subdomain.mail.com. Relaxed mode will pass that. It will treat that as the same. In other words, in relaxed mode, any subdomain of the main domain will pass just fine. In strict mode, that will fail. Strict mode says that those two have to match, whereas relaxed mode says that they have to be in the same organizational domain, and that's it. Hopefully that makes sense. I should have had examples, but anyway. And then I do have an example. I was clever. So there's your mail from domain, example.com. So in relaxed mode, it will treat those as the same. Those will be fine. In strict mode, those are totally different entities, and they'll treat them, and it'll treat them separately. So hopefully that makes sense. So yeah. Now we get to the reporting tags. RUA is where you designate the email used for the aggregate reporting. This is the email that the mail receiver will send that aggregate report to. So there's an example of what that would look like. There are tons of third-party services out there that will happily ingest these reports for you. You're going to want to do that. I mean, unless you can natively read XML, you're going to want to do that. The other thing to keep in mind is that you will get an aggregate report from every single receiving email that gets your email. So they don't work together. So Microsoft will send you an aggregate report once a day. Google will send you another aggregate report once a day. Other mail servers will do the same. And if you start adding that up, you can see that you run into a situation where you could end up with thousands of emails. That's a QR code for a tool that we use that gives you free weekly DMARC reporting. I will show you what one of those reports looks like. So I said earlier, default is 24 hours, one report for each mail server. You could theoretically, receive thousands of emails a day. Because like I said, you'll get one from every major. And if a domain doesn't, if a receiving domain doesn't receive email for that 24-hour period, you won't get a report. Because it does not report on passes, it only reports on failures. And that's another key thing that I discovered while doing the research for this. You can have multiple emails. So you can have it sent to multiple places. With regards to the thousands of emails, the reason why I bring that up is you don't want that. You don't want to set that reporting email to your email. Wouldn't recommend doing that. If you're going to catch those emails, set up a specific account for it, set a specific mailing address or mailing list for it, something like that, that's outside of your regular email. Otherwise, you'll get tons of emails. All right. And then I can break here and I will show you what one of the reports looks like. This is the one we got. This is the free tool that we use, and it gives us this report that looks very similar to this. So you'll see that it tells that it processed 20 emails were processed, none were aligned. This is a domain that we don't use, and 100% of them failed. It also goes on to tell me that, like I said, I've got it set to reject 100%. And then it gives me a nice little breakdown of who's sending email. This is the free level, so it's not much more detailed than that. For like 12 or 13 bucks a month, you can get far more detailed reports with regards to that. Like the free version will only show me the top 10 email, top 10 IPs and stuff like that. So, but this report is nice to, the top part of this is nice to pass off to someone in the, the C level basically to show them how it's going or why we need better tools. That's this website here, so it's Postmark. And my notes on the RFID tag, or at the end, I'll put it up. You'll be able to get that link. All right. The next level of reporting, and this one's a little bit more interesting, probably a little bit less utilized, is DMARC offers what they call forensic reporting. What this does is this generates an email report for every single failed email. But it includes more details with regards to like the subject and a little part of the body and stuff like that. So this is great to get that really in-depth detail on what's failing. If you really need to know who's sending on part of your domain and what they're sending, this is a good way to do it. If the aggregate report could generate thousands of emails, this report will generate tens of thousands of emails because you will get a single email for every single failed email. And again, you can specify a mail address, multiples with commas. It can be a comma-separated list. Individual reports each email. Yeah. And then this one has a subtag, which is the F0 tag, which allows you to set some other stuff. And for F0 failure reporting options, you can, I'm just going to do this. There's 4 options, 0, 1, D, and S. So you can generate a report if all identifiers fail. You can generate a report if any identifiers fail. Or you can specifically target DKIM or SPF. So this is really cool for troubleshooting. If your emails are just not arriving, you can go ahead and set this up and you'll get that forensic report. And you can see why it's failing, what's not passing. I have a slightly better tool for that, but this works. Like I said, the reporting format is XML. There is a tag that you can use to set the reporting format, but the only reporting format is XML. So it's a tag without any use currently. And then we can go to some demo. Again, we'll go ahead and use, here's the DMARC test tool. Again, MX Toolbox is pretty good for this. This will do. And so that can give you a sense of what our DMARC looks like. We've got all the tags in there. I might need to, at some point, look at that again. But this breaks down what it does, and then it gives you some indication on the bottom as far as what that health looks like. It looks pretty good. The reporting is pretty nice. That's been valuable. So going back to the percentage thing that I said, and emphasizing you want to get to that 100%, and you want to get to that reject, setting up the DMARC record, using the reporting, and running that for a couple of months will give you a sense of what's going on out there, and it'll give you a sense of when and how you can ratchet that up. So do we have any questions on DMARC? All right, I'll take that as me doing a good job. Again, this is kind of simple and kind of complex. There are my slide notes. There are some other notes on that QR code at the top. I highly recommend you go through there. I've got a little bit more detail on there, and I've got a whole bunch of, what I did is I set up a Google site, which I can show you right now. Actually, that's a good idea. My slides are not great, but the site I put up, if I can get to it, I will do, we're not quite done yet, I will show you a demo of a very cool tool that you can use to do this. I have this resources site set up. It has a whole bunch of information. If you want to read the RFCs on this technology, I've got them linked there. I've got more tools for testing and stuff like that. So you definitely want to keep this in your back pocket if you're going down this route. But last but not least, let me show you a very cool tool for testing all of how this works together. This is called DMARC Tester, and it is very matrix styled. This tool is great. You'll notice that when I bring this up, there's an email address, so you could shoot an email. So you go back to your email client, and you can email that email address, and it'll work as well. It'll ingest that email that you send to it, and it'll run through all these checks, and I'll show you what it does there too. But another one that I use more often than not, and this is great when I get those calls, hey, email's not working, I can ask them to send me the headers, and then we can come here and I can post the headers in, and yeah, whatever. When I post the headers in, assuming I have internet, come on. Why are we not working? Here we go. This goes through the headers or the email that you sent. You get the same input whether you've emailed it or whether you've punched in the headers. But it's a very clear way of showing you what's failing and what's passing, which is absolutely awesome and does a really good job. The headers that I pasted in will fail. So right there, it's run through and it said that SPF has failed. Very matrixy, which is kind of cool too. So the geek and nerd in me really likes the matrix theme. But it goes through and it does all the testing. So SPF has failed on this test, but that doesn't mean the email's not going to be delivered. Depends what DKIM does. Or, yeah, DKIM. But there is no DKIM. Again, this is linked on the site that I sent in. And it will give you an overall, So SPF and DKIM have both failed. And now you have an overall result of it not being aligned, and you have a fail. So this tool is invaluable. I use this tool very often. Whenever somebody emails me or calls me and says, hey, email is not coming, so-and-so from organization X is sending me an email and I'm not seeing that email, as long as I can get some sort of header information, I can do this test, and it can give me a rundown of exactly what's fail and what's passing, which is really cool. And again, this is linked in the notes. And with that said, I'm going to open it up to general question and answers. Anybody have any questions, answers, comments? Want to run me out the room?
I'm really sorry, but would it
Excuse
be
me.
possible for you to take that?
Oh,
Hold on, wait for the box.
This is not relevant for those playing the home game. Is it possible for you to take that short URL link and just paste that in a text editor or something, because it's really hard to tell which of those are capital and lowercase letters?
Oh, yeah. That is yes, I can do that. You can also use a QR code. Here, I'll do this. Does that work? Can you see that?
All right, so we'll
No,
just do
I can make that bigger.
sites.google.com/view/rise of the triad-email. All right.
You can also take an RFID tag. All right. Anybody have any other questions or comments about the stuff? I mean, it's bizarrely complex, but not, in my opinion. And it's been an interesting journey setting this up for us.
your last point, when you said when somebody comes to you about undeliverable mail and you just wanted headers to paste into that last site, exactly what headers are you getting? Like from a bounce back, or what are you asking them to supply you with to feed to that site?
It depends on what I'm trying to troubleshoot. If they've got the email and it's in their spam folder,
Right.
then I can walk them through getting me the
And you
headers.
get the why is it spam from that.
Correct.
But if they're
And that
saying,
tends to be a lot of times when I hear about it is it's landing in spam. If they're not receiving the email at all, that's
Right.
obviously more comcomplicated. Because
that's why I was having trouble figuring what headers would you be getting, because you don't have them.
Yeah. The most common calls I get are either bounce backs, which is frustrating because the bounce back usually tells you exactly why it's bouncing back.
Yeah.
And most people don't read, so there's that. But the spam one is probably the most common one. The second most common, if I get that call, hey, so-and-so at organization X is sending me an email and I'm just not getting it, I would have to coordinate with them. And I can tell them to send an email to that, the DMARC tester email, and then they can do that, and I can get the report from there.
Okay.
So because we don't have control over the sender, and most of our users think we do, it's kind of hard to sometimes troubleshoot these issues. I mean, I've literally had to tell end users that I can't help you. It's not that I don't want to help you, it's that I have no control over what they're doing on their end.
Of course.
So most organizations, though, if you get the right person on the phone, you can usually coordinate and solve it, because if you're not getting their email, other people are not getting the email too. So, but what you can do is you can use the other tools and their domain to look up their SPF record, to look up their DMARC record, to look up their DKIM record, and you can verify that they are correct looking. I have done that. I have coordinated with a couple of other second-party organizations from us, gone through, looked up their SPF, and be like, that's wrong. That's why your email's failing, because you don't have this key. And then again, getting in touch with someone on their end that can make that change. So, email is a pain in the butt to troubleshoot sometimes, because you don't have control over all the pieces. Anyone else? Questions, comments? All right,
I'm good. Can I do one more then?
go ahead.
Do we have any tools, anything to help us when the short name, the human, I forget the proper field name,
The
but
organization?
no,
domain?
the human-friendly name,
Okay,
when you see Barack Obama
okay.
in there, but it's not from president@whitehouse.gov. It's from a different email address. So, the idea is the malicious agents are putting in a VIP's name in some other email address. And the email address, everything could be legit from the user at domain send and all the analysis side. but the friendly name is made to deceive somebody to do something bad. Is there anything we can do outside of the obvious of user education?
No.
Yeah, I didn't think so.
If it's coming from obama@gmail.com, everything
Right.
passes, everything's legitimate.
Right.
From a technological standpoint, that is a legitimate email.
Truth.
Some
Yep.
systems that will read that, like,
Yeah, Google will flag.
if
Google,
I send an email from myself from one of my domains, if I send email from myself to one of my domains to email at myself another domain, and they're like hosted at Google, sometimes Google's like,
Google will flag
this
that.
email came from someone with a similar name in your organization.
Yeah, we see that. We
Be
see that all the time.
cautious.
Not globally applicable too.
Well, yeah, it's not globally applicable, but we do see that, and it does curb quite a bit because when someone sends an email to my people from my superintendent, and Google flags it, hey, this person has a name similar to somebody in your organization, big yellow banner at the top, you can't miss it. So there are a few kind of tools that can help with that. It'll vary, but for the most part, user education is going to be your number one key for that. Users need to verify the from address. I mean, if it's obama@gmail.com, it's probably not President Obama. I mean, so, and that's another reason why DMARC deliberately picked that from header, because that's what the end user sees. And it's the most universal part of email. Right? In the back corner, you want to pass the throw box back there?
To the same point, Microsoft 365 has options that will also flag if it's not in the user address book or the global address book, and that if the name matches but the email doesn't match what's in the address book, it'll flag it. Okay, but it depends on which level of Microsoft 365 subscription you have and what option you've turned on, and if it's Thursday or Friday, and
So in my notes as well, just to add, with regards to the DKIM setup, I've got links for Google's documentation on how to do that and Microsoft's documentation on how to do that. I didn't go beyond that because it really varies past that. But those are the biggest ones that you'll run into in the sort of education field is Microsoft and Google. So, and setting up Google's, because I've done it, is trivial. So if you don't have DKIM set up, do it. It'll take you literally 10 or 15 minutes to do. All right, with that, I think we're, one in the back there.
Excuse me?
You want to grab the catch box?
I just wanted to add to that, if you're setting this up for like a client, at least in my case for Google, if you were just recently, adding your records to that domain or for them as an email server, it can take a few days for them to allow you to add these additional records from what I've experienced. So keep that in mind.
I could see that. When I set it up, we were very well established with Google, so I don't remember it taking any lag time. I could generate the key immediately, but.
I'm sure that's good stock. People returning.
Yeah.
I've done a few for a client recently, and yeah, it's 24 to 72 hours.
Yep. Maybe it did take, I don't know. It was a year or two ago. Yeah, we have a very well-established domain and a very well-established Google account, and we dived into SPF and DKIM. I had DMARC set up, I don't know, a year or two ago. So we were very early adopters of that, primarily because we were spearfished so much. I mean, the amount of spearfishing we get is insane. So, all right, if there's no other comments, then I think we're done here. We got 51 seconds. Thank you.